Good evening, everyone. I hope you guys can see my screen and I'm audible. Could someone confirm me? All right. Okay, thank you. Guys, so let me quickly tell you about this course. So, as you already, some of you have attended in the last workshop too. So, let me tell you the module that I am going to start, the Cisco ASA FTD, which is part of three courses that we would be launching next weekend. The first one would be Firewall Mastery, so which consists of five technology or five firewalls: Palo Alto, Checkpoint, ASA FTD, FI LTM, and FortiGate. Okay, so those guys who are interested to take this, so we start with this module. Especially someone who is looking from the Cisco certification. Then we also are launching two more track, CCNP and CCIE Security. So CCNP Security consists of two paper, the mandatory paper and the firewall paper. Okay, two papers. Once again, this is the start of CCNP Security. And in the case of CCIE Security, we would have couple of more modules: score paper, Cisco ICE, Cisco Firewall, the email security appliance, web security appliance, and the CCIE security bootcamp. Okay. So those guys who are going with the third module or the third course, once again, ASAFTD forms the first block that we would start with. So anyone who is interested to take Firewall Mastery, for you, this is where you start, and then you will get into Palo Alto or FortiGate and so on. You will be in this module. Someone who needs CCNP security, you will have two module, and someone who is taking the complete CCI security, you will have couple of more. So this is 4 to 5 month every weekend, Saturday, Sunday. This is 3 to 4 months, and this is going to be 5 to 6 months. We provide the dedicated lab for each of the track, so don't worry about the remote access lab, the home setup. For most of the time we would be providing you the remote lab. So with Firewall Mastery you will get around 5 months. With the CCNP security you would get the lab for 3 months. For CCI security you would get it for 5 to 7 months, and at the time of appearing for your CCI exam you would get this. Yes, you can skip everything and do CCI security. That is doable. But then you know the modules that we are going to cover: score, ICE, ASA, FTD, ESA, WSA, and CCI security. You will not be having any other modules inserted here. You don't have Palo Alto, you don't have Checkpoint, neither FortiGate, neither F1. Okay, so these are three different modules, three different courses. Whichever you opt, we are starting with the ASA first, and then accordingly the progress would be we will see the progress. Okay, three different courses, so you can select whichever you want. All right, so in the last class I gave you a quick introduction on firewalls, what are firewalls, and the types of firewalls. We did a basic overview on the FTD, FMC, and Palo Alto. Today, I'll start with very basic class. I'll take up a topic from ASA, Cisco ASA Firewall. and then we go topic by topic. Okay. So ASA is a abbreviated name. The full name of this adaptive security appliance. Most of the firewalls are referred with the name appliance. So don't get surprised if I don't call firewall and I call appliance. Remember, appliance are firewalls itself. So the full form of Cisco ASA is adaptive security appliance. And this ASA is a first gen firewall. It's also considered as a traditional firewall. That means this firewalls can work only on layer 3 and layer 4 of OSI layer. They do not work on the topmost layer like 7, 6, 5. They do not work. So that is why the ASA module was end of life after around 15 to 20 years. It was end of life like last 2 years back, might be in 2020. Then why do we still have ASA with us in CCI or CCNP? Because ASA was introduced with the next gen firewall. Okay, what Cisco thought is it's not a wise idea to recommend the customer to take off ASA box and deploy a complete new box. So what Cisco did, Cisco introduced new capable devices with firepower series. So for example, if there was a device 5515, so Cisco introduced something which can capable of next gen. It introduced something called 5585X. So wherever you see this X, that means they are next gen firewalls. Okay, they are nothing but they are ASA plus the next gen firepower series. How did Cisco acquire this? So you know Cisco is very popular in terms of acquiring new technology. So there was a company called SourceFire some year back who were into the next gen firewalls, and they had a process called NOT. So this company was purchased by Cisco and they renamed it as Firepower. And this next gen firewall, we started seeing getting integrated with the ASA boxes. So this is how ASA with firepower technology got introduced. Now, after a few years, what we now see is a complete new box, which are proper FTD capable. We don't call this box as ASA box. We call it as fire threat detection box, FTD box. So nowadays in market, you will find ASA plus firepower. The older ASA are actually being taken out now. They are end of life. Hardly you will see anyone using this, but they are replaced by ASA firepower, or you will see the FTD boxes, direct FTD devices itself. So since we are having ASA firepower, we still need to know the fundamentals of ASA. That is how you will understand how the firepower would work. Or learning ASA also helps someone who is a complete beginner in terms of security or firewalls. So for you, ASA firewall is the first thing that you should think about learning. So let's talk about Cisco ASA firewall in general. What is Cisco ASA firewall firewalls? Okay, in general, I'm talking about the same fundamentals you can apply on different vendors. Most of the things would remain same. So let's assume this is ASA firewall. They have the input output ports like regular devices. So they have ports all in a gig interface, and they have a output ports. Okay, so let's say there's a input port gig 0/0, and there is a egress port gig 0/1. Now if a ingress traffic tries to enter, ingress or incoming traffic, the first thing ASA would do is it will deny this. If it is a brand new firewalls and you just plugged it without configuring any policy, the first thing firewall does it to deny this. Now that's not a good solution, because you will lose the connectivity between inside and outside. So what you would do is you would add the necessary policy. You would say that if any source IP belonging to this source and this port, if is it going outside, you would like to allow this, and rest of the connection you would like to keep it denied. This is called packet filtering. So you will apply that ACL here. And what type of ACLs you apply it on a firewall? We apply the extended ACL. So you know that ACL consists of two types, standard and extended. So firewalls will only use extended ACL. So I'll apply this policy called this source, this port, this destination IP, this port, allow this, and rest of the traffic I would like to still block it. So now if I receive a ingress traffic, if I see the policy is matched and the action is to allow, it will go via different process, and then it will check the routing table. It will say that this is the outgoing interface or a egress interface. Okay. Now some people, especially if this firewall was kept in a major data center, some people would like to keep an egress policy also. They want to keep an egress policy too. So they can keep another ACL. So at this time, you need to take care of policy over here plus over here. 2 times. Remember that. That depends on the design. So you need to check if there is any implicit deny policy applied on a egress interface or only on the ingress interface. You will check that, and depending upon that, you will add the policy. Okay, so this is a basic fundamental. But what exactly would happen in the case of packet flow? So we will discuss about packet flow now. Let's assume I got one firewall over here. I have another firewall over here. So let's say this is ASA 2, this is ASA 1. There are 2 transport methods here. One, the internet, ISP. The second, in case you have a tunnel, a VPN tunnel over on a shared infrastructure. And behind this, let's assume you have a user, PC1, and behind this also you have a user who is PC2. Okay, so this IP is 192.168.1.1/24, whereas this is 192.168.2.1/24. And intermediately, let's assume that the IP over here is 192.168, let's say 100.1. Let's say this IP is some public IP. Let's assume let's assume 211.1.1.1. All right. So let's build some scenario now. So this is where we will discuss about packet flow. How is ASA gonna treat the packet? So there are a couple of steps here. So just listen it carefully. Let's first build the scenario that traffic has originated from this point, origin, and this is considered as the destination. So what is my source IP? So my source IP is 192.168.1.1. Destination IP is 192.168.1.2. Okay. So let's assume this is the first packet which has originated from PC1. Where is this traffic gonna hit? It's gonna hit on the ingress interface. The minute ASA will receive any packet, it will start with this functionality. So I would like to keep them in a different steps now. So let's say on the ingress interface, if this is gig 0/0, so let's say that is a step number 1 where you receive the ingress traffic on gig 0/0. The second step that would happen is the interface buffer, the buffer of that interface will increment with +1. If it is a first traffic, there would have been okay, let me correct this is 2.1. Okay, so as soon as as soon as the packet is received on an interface, the ingress interface, the buffer will be incremented by 1 counter. Let's assume this is my first packet, so it has a incremented by 1. The third step that happens is the connection table. The connection table, it's nothing but the stateful feature of a firewall. We discussed yesterday about this. Is this a new connection or is this a existing connection? If it's a new connection, then what happens? It will build the connection table and then go to the next step. If the connection is already built, then it will bypass couple of steps and then get into the next. So let's assume this is a very first traffic. So the connection table will be built. Once the connection table is built, the TCP state will be checked. TCP state or UDP state, the three-way handshake would be checked. Later, is the traffic translated or untranslated? So in this case, at present, this is a untranslated traffic because the traffic originated from inside a network. It's not coming outside where I have applied the NAT. So right now it's a untranslated. Later on, it will go to the ACL check. Okay, the ACL on this interface will be checked whether it's allowed or denied. If it is denied, it will drop at this step. If it is allowed, then it will go to the next step. Next step is modular policy framework. So this is a concept in ASA where you can tweak the QoS and other properties, which is called modular policy framework. It will check that. Then it will go to next step. Is it a next gen firewall module? Yes, no. If yes, then you might have introduced something for anti-spyware, antivirus, device ID, or FTD features. But this is a proper ASA firewall. It do not have any next generation firewall right now. So that's going to the next step. Next step is route lookup. It will see where is the destination. So the routing is happening later once you have finished with ACL and translation connection table. Later on, after the route table, you will check the translation. Now this translation is from the source perspective, because here you might be pushing a inside traffic to outside. So the traffic needs to be translated, right? You have a different sort of translation, PAT, dynamic translation. So that will happen here. After translation, it will check, is there any IPS module? You know that on a ASA firewall, we can insert the additional blade for IPS. But nowadays, in a latest next gen firewall, the blades are already present. The UTM blades are already present. But in a ASA firewall, we had to add that as an additional thing. Later on, the egress interface is checked to see where the traffic should live. It will check then whether it's a VPN traffic. It will check then what is the L2 path or the next hop. It will see where is the L2 path here, and then the traffic is considered to be transmitted. Okay, so this is the step that would happen. So now let me put that in a presentable way. So this is a traffic, this is a packet. It enters the ingress port. What is going to happen? It will check, it will increase the buffer. It will check whether connection table is present or not. If the connection table is present, then it will bypass couple of things. But in my case, this is the first packet. So it will first see the TCP state, the three-way handshake. If it is a UDP packet, then it will rely on a unreliable communication. Is it untranslated or translation? Let's assume that it's right now, there is no NAT rule. So this is not applicable for now. So this is, then it goes to the ACL. ACL is very important. This is a mandatory step. You should allow the action yes or no. So let's assume that you have put the policy yes. That means you want to allow this. So once it reach to the ACL level, then it will check the MPF modular policy. It will check the next generation. It will then check the root lookup. So this is right now, let's assume, not available. In the root checkup, it will see that to reach that 2.1, you have two paths. You can either send via this or you can send via this, correct? Both will work. You can send via ISP, you can send via VPN. But then you check the next step. Next step is 10. 10 is translation. There is no translation rule as of now. But then in the next step, IPS, that is also not available. 12th is when the packet is about to leave. And in the 13th step, which says VPN, so under the VPN, you might have put some rules, some matching parameter. So you might have said that my source packet should be 192.168 and 1.1, and destination should be 192.168.2.1. As soon as this is matched up in the 13th step, your traffic will not take this path. No, it will not take the VPN path. Instead, it will take, sorry, it will not take the internet path. Instead, it will take the VPN path. And then the L2 next lookup happens and the packets are transmitted completely. So this is in the case when you initiated a plain traffic, no NAT as of now. Only the roadblock was whether it takes the internet path or the VPN path. Now, this is the scenario one we discussed. Scenario one. If I discuss about another scenario, scenario two, for scenario two, I would keep some NAT policy. Let's say that my private network 192.168.1.0/24 wants to reach 8.8.8.8, which is, let's say, Google or internet. So I have to add a NAT policy. You know the term PAT, right? Port address translation. So I will add this. Let's assume that I have picked up a public IP so and so 211.1.1. This is the public IP. So for all my private to public communication, it will take this and then it will go out. So where would I put this NAT rule? I would put it on the firewall. So my NAT rule would be something like NAT from inside going towards outside, source dynamic, and then I would say any 192.1.0. So this will now fall under this 1.0. And let's assume that I keep it as to reach 8.8.8. Now the packet is confused at this step. Why? Why is packet confused? Let me tell you. Let me just remove these markers. See, in the scenario 2, when you have the NAT condition from private to public, you will once again follow the same path. The ingress traffic will come here. Counter will increment. The connection table will be checked. Let's say it's a new connection. The TCP state will be checked. Right now, let's assume this is let's assume that this is going to be the a non-translated thing. So let me keep it as non-available. The ACL will be checked, which is let's assume it's to allow. These are not configured, so not available. Root lookup will be checked upon. So when you see the lookup, you will see two paths. You will see a VPN path, plus you will see the internet path. Agree? Because at this point in the root lookup, it has two ways to reach, let's assume 8.8.8, the far end. But then there is something called translation. This is a source translation, which is before VPN now. Agree? So the NAT rule is checked here. So when the NAT rule is checked, you will see this falling under. You will see 192.168.1/0/24 complete class C traffic 254 users are being asked to do a NAT and then go out. So what happens? Your genuine traffic, the VPN traffic, also get triggered by this NAT rule, and it will take the outside route. So here it's gonna go outside via this route because the NAT rule is before the VPN. So what happens when it hits the NAT? NAT will check the IPS. IPS is not available. Ingress is decided. Let's say now the ingress is so and so. VPN is not available because, however, the NAT has changed the source IP. The packet would be different now. See, for example, the source IP here was 192.168.1.0/24, and destination IP was let's assume 210.1.1.0, or let's say 888. This was the destination IP. Once it go through the NAT process, you know that source is set to change. Now you will keep 211.1.1.1, and the destination IP remain the exact thing. Now, once this has been changed, your VPN will not allow this unknown traffic. You know how VPN work. For VPN to work, the source IP should match with whatever IP that you have set, the remote IP, and as well as the network that you are allowing. Only then the ACL, the VPN ACL will allow this. So at this condition, in the scenario 2, since you have translated, the VPN, however, will not work. So only way to reach is via internet. Okay, so this is what happens in the scenario 2 when you add certain when you add certain NAT policy. So scenario number 3 is, how do we bypass that? How do I take VPN traffic over VPN, and how do I take the remaining traffic over on the internet? So for this, we need identity NAT. What identity NAT does it's a type of NAT which will source the private network and convert back to the private network itself on meeting some condition. So my identity NAT, if I have to write it, I have to write it this way: NAT inside, outside. I'm gonna put a static because I know which host I want to send over via VPN. So I will say my static host 192.168 1 dot, let's assume 1, the host, or if I want this particular network to be converted to the same IP. I don't want to do a translation to another public IP or something, to the same IP. If the destination is this guy, this one. Okay, because if PC2 and PC1, then I want it over on VPN. If it is any other traffic from that user, I want that to be over on the internet. I don't want to burden my VPN traffic. So I can put a condition. If destination is 192.168.2 dot whatever 0 or 2.1. So at this point, I expect this to go via VPN. So now what happens? This identity NAT, you need to keep it on top of this rule. NAT inside, outside, static 192.168.1.1 or 1.0, 192.168.1.0 if condition originated from this destination. You know how NAT and ACL work. They work in a top to bottom fashion. So this would be like, let's assume one, then this would be the second. So let's see the packet flow now. Ingress interface, buffer counter increased, connection table created, TCP checked, it's inside originated. So once again, not applicable. ACL is allowed, not applicable. Next gen, not applicable. Root lookup will be done. And during the NAT translation, first the identity is kept in a sequential order. So this will be checked. And as per that, you have put a condition. If by PC2, then only identity get triggered up. If that is the case, then it will take the step number 13 and it will go via the VPN tunnel. For some instance that's not meeting the condition, then you have your other NAT rule where you want to mask it with a public IP, right? So as soon as you mask it with public IP, the VPN, however, will fail. The condition will not match up. So it will take the internet connection. So this is a packet flow that happens in a ASA firewall. Every vendor has their own mechanism. I don't want to confuse today, but I'll just give you a short brief. When we go towards FTD, we will talk about the SNOT process. When we go with a Palo Alto has its own 3-tier architecture, the packet flow for this. CP has its own, FortiGate has its own packet flow, and FI LTM also has its own packet flow. Okay, packet flow is very important when you appear for interview, plus when you troubleshoot any of the scenarios. So you need to understand what is trying to overlap or override the default configuration. So I hope this was clear when it comes to the packet flow with Cisco ASA. Okay. Let's talk about the Cisco ASA deployment. As you know, they have a hardware and a software or cloud or virtual. So in the lab, we are using the virtual instance. So it's called as ASAV, V for virtual. And the latest software is 9.x. So we would be working on 9.x. So the CCIE Security has a major portion for ASA 9.x. So topics like AnyConnect, the VPN, the interface configuration. So these are some basic things or frequently asked expected thing from the firewalls. So how do we configure ASA firewall? I'm talking about ASA, not about the FTD, because if you have FTD, you have almost everything to be done from graphical. But when it comes to ASA, you have CLI, which is majorly used. You also have ASDM, but ASDM are locally significant. They are not centralized. So if you have let's assume multiple ASA. So it should have its own ASDM. So the things would become bit on complexity to manage them. So the best option would be CLI only. You can quickly go and put the command and the things will work. Most of the CLI commands are your catalyst command, but with some differences. So when you do show version, you see the license and other details. In the ASA firewall, we have show interface IP brief. Whereas if you know that in a routers, you have Cisco IP int brief. So this is something different. Rest, you don't have show IP route, you call it as show route. Okay. Then show log. So most of the things will work as per the catalyst for a ASA firewall too. All right. So let's assume what are the basic things that we need to configure inside the ASA interface. So let's assume I have a interface gig 0/0 and I have a outgoing interface gig 0/1. So how do a firewall normally work? So if I send something, some ingress traffic, will it go instantly out? That we have already checked the packet flow. There are around 15 steps that happen. But how we talked about something called ACL here. So step number 6, ACL, was a very important step, allow and deny. So how do you add them, or how do that gets checked upon? What makes them to understand in the case of ASA? Once again, this is a different concept in ASA versus Palo or any other firewalls. In the case of Palo Alto, when you receive a packet sent to another egress or any other destination, the ACLs must be present because this interface will be part of a zone and this would be part of a different zone. So when you have two different zone, you need to have ACL with a permit statement, allow statement. Only if they are in the same zone, the zone is same, then by default they are allowed. But any zone to zone, a zone is nothing but a logical name. So let's say you keep the zone as inside, you keep this zone as inside, and this zone you name it as outside. So inside to outside, outside to inside, two different zone. You need to have ACL. Inside to inside, same zone. You do not need any ACL because there will be two predefined ACLs in the case of Palo Alto. So when you go to the dashboard of Palo Alto, under the policy, you will see two ACL rules predefined. If it is same, then you allow, that is what it is written. And if the zones are different, then you don't allow, you block it or drop it. So now whatever policies you need to allow, you need to add it on top of this. So you have first policy, second policy, third policy. So whatever allow, deny, whatever you want, you will add on top of this. But in the case of ASA, there is no inbuilt such ACL. The only ACL that they have is to deny. Until you have any permit statement, it will consider as predefined deny only, implicit deny. Okay. So how ASA are different than Palo Alto? In the case of ASA, we have a concept of security level. The ASA firewalls are having the concept of security level, which starts with 0, goes till 100. So 100 being the highest secured, a very secured one. So you would give that interface as 100. 0 considered to be risk or towards the internet facing interface. So here I would give the security level as 0, and over here I will give the security level as 100. So remember, ASA don't have concept of zone. Zone firewalls are these ones like the Palo Alto, FortiGate, whereas ASA works in a concept of security levels. So as per security level, there are three thumb rules. If it is higher security level to a lower security level, what does it mean? It could be from inside to outside. Without a policy, you have a allow statement. In the case of ASA, you don't need any special policy for that. Okay, if the condition is meeting higher level to lower level, from 100 to 0, 99 to 0, 50 to 0, 40 to 2, 30 to 5, because the levels are configurable. You can say that this you are making as 5, security level 5, and this you want to make a security level 90. So 90 towards 5. Once again, it's an example of high to low. So by default, this will be allowed. You don't need to write any special policy for this. Remember that in the case of ASA. In the case of lower level, that is something coming from outside towards inside, this is completely denied. It is completely denied. Now, how would your customer who are outside wants to access your server would come? So for that, you need to apply the policy, permit policy. So once you allow customer X to reach this server on this port number, then this will work. Otherwise, all the lower to higher is implicit deny. What is the third? Third one is same to same levels. So it could be anything. It could be 0 to 0, same levels. It could be inside to inside. This is also considered as a same security level. So by default, this will not be allowed. This will be not allowed. But there is some magic command. There is a command. Once you input this command on the firewalls, then you can allow the traffic. And policy is still not required. No policy needed. The same to same will work, but by default that feature would be disabled. So you have to add that command, magic command. It's a command like same security level interface. So once you add that command, it will work and policy is not required. But then let's assume that you need some filtering, right? Because then all the users behind this, there could be multiple users behind this who are trying to access the server behind this. So adding the magic command can create a loopholes. So for this, you can add a policy. You can add a policy that I want to allow only this guy to access the 3 servers. The rest I want to deny it. So you will go to policy, you will allow the first guy, and the remaining 2 guys you will deny it. So this is done in conjunction with this magic command. Remember that. So this is when it is same to same. So any doubts so far? Are you following me? Okay. Have you thought about the configuration of firewall interface? How is that look like? What are things that needed? As I told you, most of the things would be uh, as good as the catalyst in the case of ASA. So you go to the interface level of this gig 0/0. You can put a description. Let's say you want to name this as a input to, let's say, switch 01, some description. You can assign a IP address, very regular command, 1.1.1, 255.255.255.0. There are two special commands that you need to add. One is nameif. What are nameif? Nameif are the security or what the zone. I don't call it as zone, because if I call it as zone, if I call it as a zone, then the example would get changed. So I would call it as nameif. Nameif in the sense, what name do you want to give it to this interface? So let's say you want to keep it as inside. The minute you put inside, automatically the security level command will get triggered up, and it will set this as 100, because you know that inside has a higher security. But in case you wanted to keep anything else, like you wanted to name it as DMZ1, outside, so and so, so and so. So this security level in that case would be 0. But as you know, these are configurable between 0 to 99. So you can go back, add this command manually, and say that you want to set it as 100. So a firewall can have multiple interface with multiple security levels, so that high to low level gets implied. So let's say this security level you set as 10, though this was inside let's say payroll, you kept the name if as this, whereas this you kept as 100, or not 100, let's keep a bigger number, let's say 90. Then you have a inside, then let's say this is inside for server team or something, so you kept them as 85 security levels, whereas this is going to outside customer 1. So you know whom you are sending. So let's say you kept a low security level of 10. This is going towards outside customer 2. So you know who those are. So you kept a security of 15. And for all the generic traffic, all your messenger, chat, etc., which you're not sure, you can keep the security level as 0. So this is changeable with the help of this command, security level, and you can set whatever is needed. So why we do this is because we know what happens here. So you can have more control. Otherwise, if you would have kept for all inside a fixed one, they all would have started communicating, or someone from the server team could have pinged or unnecessary broadcast, etc. So instead of that, we can keep them in a higher security levels but lesser than the what we have for inside. Same way, the outside, instead of keeping 0, we can keep it 10 or 15. So this up to the design team how they come up. All right, so this is some theory for today. We will quickly do one lab. So as per the lab, I will show you the basic commands that you need to trigger on ASA firewalls, basic CLI commands, and we will do a small lab where we allow traffic from inside to outside. So I will not go with any access list as of now, because I don't think we have so much of time. So we will just do a basic inside to outside. And in the next class, for the enrolled guys, I will start from the scratch. So this is just a 2 demo. Whatever we covered, I will once again start in the logged session. That would be in the next weekend itself. So where we start this from scratch. Okay. So what is the lab that look like for ASA? So this is the lab for the firewalls. We have FTD, FMC on the left hand side, and on the right hand side you will see the Cisco ASA firewalls. See, these are the Cisco ASA firewalls, and on the on the left hand side you have FMC, FTD, and all those things. Once we do certain portion or syllabus for ASA from CCNP CCI level, then I'll start taking you guys to the next generation firewall of Cisco. Okay, so today I'll show you for ASA firewall. Let me open up the console. When I open up the console, this is what I see. This is, or let me do one thing. Let me start it once again so that I can do a fresh configuration. So I just powered off and powered on them. So here, what is my agenda? My agenda is from this computer, the computer over here, PC1, I would like to go out. Let's say this is internet or outside. My firewall is here. Correct? We know the security rules thumb rule. So let's say if I assign this as 100 and I assign this as 0. So what is expected behavior? Will it allow or deny as per the 3 thumb rules we discussed? Yes, it will allow it because high security level to a lower security level. Okay, not deny, it is allowed. Okay. That in the next class, I will show you the different scenarios. I can change this to, let's say, 50, and I'll keep this as 100. And then we will see how do we add policies and all those things. So today, let's keep it basic for the audience. Let me open the console. Let me open a console for this PC, reconnect, ASA firewall, most needed, reconnect. And then I have is the router. So router is acting as a outside interface. That's all. Okay. So these are VPC machines. Not sure if they have some IP. So we can quickly add one IP addressing here. Okay. So how do we add the IP here? So we can add just by this command IP. Okay, let me also put the addressing, IP addressing. They are already present. I'll go with 10.1.100 here. This interface I will set as 10.1.1 so that they fall in a LAN network. And over here, I can keep any public IP like 211.1.1. And this side, I'll keep it as 211.1.1.2, something like that, some public facing. And this is a local area network facing. So let's do quick configuration. On this, I say 10.1.100, subnet mask of 255.255.0. My gateway, next hop gateway for this computer is the interface of that ASA firewall, correct? So I will say that firewall would have this IP. This is how we add a IP address on the computer machine of the lab. So you want to check if it is added, you can make use of show IP command. You see the IP assigned to this machine with the subnet mask gateway. So this gateway is nothing but it's the gig 0/0 of the ASA firewall. So I'll go to ASA firewall now. enable. Let's do directory. Let's do show int IP brief. Everything blank. So I'll go to conf t or configuration terminal. It is gonna ask me, do you want to enable? Yes, no. Let's say no or whatever, and just come to the global configuration mode. So first thing you change, or let me first put it in a notepad in a proper way, because for most of the guys might be this is a new thing. So first thing that I would put in the ASA is the host name. Then I go to the interface. This is a gig 0/0. I'll change the description. I'll say this is connecting to the inside or the LAN part of it. The IP address, as we discussed, would be 10.1.1.255.255.255.0. When I put this command name if inside, automatically the security level would take it as 100. If it don't, then this is the command to modify it. Security level 100. Okay. Similar way, I'll go to the outside interface that's configured on 0/1, I believe, right? Yeah, 0/1. Okay, let me keep this and let me have this here. So this is now gig 0/1. Now this is towards outside, let's say ISP. The IP I would like to set here as per the diagram 2.1.1.2. Let's say 1 here. Security level or name if is outside now. So this would be considered as security level 0. So this configuration will go directly to the box, ASA box. Now remember, since I'm not adding any security policy in today's class, I'm just keeping ping traffic. Ping is considered as a stateless by default in ASA firewall. So what would happen in ping? See, I'll say that, let me put it this way. I finished my configuration and I want to test it. So how do I test? I will do a ping packet from PC1 to PC2. But ping, which are nothing but ICMP packet, they are considered by default as stateless in ASA firewall. So we need to remove that feature. We need to remove that feature and we have to make ICMP treated as stateful. Why? What will happen if I still keep it stateless? In this case, you need to put bidirectional rule. So you know how the ICMP work. There is a echo packet, right? ICMP echo request and ICMP echo reply. So this will carry a code of 8 and this will carry a code of 0. So the return traffic of your ICMP, see, the first traffic will be allowed because of 100 to 0, higher to lower. But the return traffic, which is outside to inside, that will get blocked or denied or dropped. Why? Because your ASA by default is treating as stateless. So that is why I said, let's not fall under writing a policy, at least for today. Otherwise, I could have written a policy. I could have put a rule that allow this. But today, not. Let's go into much deeper. So today, I just want to do this ICMP to be treated as stateful. So that what happens is when you ping from PC1 to PC2, the stateful table gets created up. And all the return traffic is considered as a allowed itself without adding any additional policy. So this is something which we need to do it. Okay, on a ASA firewall, which by default would be not enabled, along with this few things. Okay, now I'll go to the firewall. Since I've already shown you in a notepad, so I can go ahead and I'll just directly type it. Interface gig 0/0. Description, I would like to put this as inside local area network facing. IP address 10.1.100. Sorry, not 100. 100 is of PC. So let me keep this as 1. 255.255.255.0. Name if inside, it has already set the security level by 100 automatically. But if I would want to keep it different, then you know that this is the command. I can go and keep it 90. I can go and keep it 85, whatever my implementation team asked me to do. For now, let's keep it 100. So this is one of the interface. I come out of it. I get into another interface. The description of that interface would be outside, which is facing internet. The IP address I would keep is 211 1.1.1 255.255.255.0. Name if outside. So security level by default has become 0. Once again, if you don't want to keep this as 0, you can go and modify. Since this is a outside facing, you can keep 1, you can keep 5, anything of your choice. Okay, so two interfaces are configured now. Now, I told you ICMPs are by default considered as stateless, right? So how do we how do we make this changes? First, let's check where do we get to see. So if you do show run section, global policy, let me go with begin. See, when you go with begin, by default, these are the traffic that is considered to be stateful by default. Rest you need to add. So right now, ICMP is not getting treated as a stateful. It is treated as a stateless. So what you need to do is, since you don't want to fall under policy writing for today's class, so you just want to enable the stateful feature. So what you do is get into the policy map question mark. You should remember the name. So it's called global policy in ASA firewall, question mark, class, question mark. It's called inspection default, question mark, inspect, question mark, and which traffic you would like to treat as a stateful. So for now, I want to only bring the ICMP, not everything. So now if I go once again to this, you should see the ICMP has been added up by me. Okay. Why I did this? So that my reverse traffic is not getting dropped because I'm not adding a policy for now. That is why I just want this to be a stateful feature as of now. Okay, so this is something which you do it on a ASA firewall or the first attempt. And second thing that you normally do is that same zone to same, not same zone, same level to same level. I said by default they would be turned off. So you would like to allow same level to same level. So the command for that would be same security permit interface. So this magic command will allow same level to same level communication. And rest of the policy traffic or traffic management, you can still handle it using the policies there. You can say this PC to this PC and deny all others to this destination, something like that. All right, we have configured the ingress interface, egress interface. The ICMP are being stateful. So what are we waiting now? We are waiting for the second, the router, which is in a outside level, internet facing. So which interface is that? The interface is FA0/0. So I go to configuration T. Let me name it as internet router 01. Interface FA0/0. I'll call this 211.1.100 255.255.255.0. Description, I can add it as internet or internet towards ASA's outside interface, something like this. Okay. And also remember, we need to keep a written traffic path. See, what will happen is now your traffic will start initiating from here. It will go to the firewall. Firewall will push to the router. Now, what router will do? Router will not have a reverse path with itself, because we are not enabled any IGP protocol. We don't have any OSPF, EIGRP, static route or something. So the written path, due to not having the routing table, it will drop it. It will drop it saying that I don't know how to reach this guy, this particular guy. So what we will do is we will put a static rule as of now. I'll say any traffic that you receive, don't drop, just send it to the firewall. And since firewall is already directly connected to this network, it will push it. So it's called a static route. I'll add the static route here in the outside router. IP route, any traffic you receive, don't drop as of now. Instead, send it to the next hop. So next hop is 211.1.1.1. This guy, which is nothing but the firewall guy, the ASA, the outside interface of ASA. So we have done all the configuration. We are good to test now. So how do I test if my traffic is flowing from inside to outside? I will ping this IP 211.1.100. So where is this IP? This IP is nothing but this one. So I'm initiating a traffic, which by default would have been denied. But since I've done the necessary configuration, so it should have a ping reachability between these two. Okay, so let's give a ping check. I can add some count or repeat packet of 10. So it says that it's unreachable. So let's see why it's unreachable. Are we missing out some IP? Let's check that. So let's see, do show IP int brief. See, the interface is still admin shutdown. So it says that the host is not reachable. So what I do is I'll go to that interface and make it no shutdown. Let's hope the ping will start working now. Let's put some count as well. Okay, now let's see what is a new issue. So if I want to recheck this, 211.1.1.1 is fine. Let's do a ping to its connected firewall. See, 211.1.1.1 is not working. So let's see, is that the right IP on firewall? No, it is 1.1. Oh, yeah, it is 1.1 and IP is okay. Both are admin down. See, so this is how you troubleshoot. Make it no shutdown. Interface gig 0/1, no shutdown. Then let's give a test. See, you have the working ping facility now. Right? Let me put back the interface because I want to show you some troubleshooting step. Let's say I put the interface gig 0/1 has shut down. The minute I put my outside interface, which is connecting with the outside world, what will happen to the ping? Ping will definitely stop. So if you try to ping now, ping is not working. It says timeout. How would you do a troubleshooting in a network? So we can apply some packet captures. So as a firewall engineer, first thing that you need to check when someone says that this to this is not working, First thing you need to check is if the policy is allowed or not. Second thing you can check is packet capture, whether the packet is really flowing through this firewall or it's taking a different path and you're wasting your time by checking the policy on ASA. So these two things really helps you. So let me first check the policy, if policy is present or not. So there is a command called packet tracer input. You're expecting the traffic from inside security level. This is a ICMP traffic. Enter the source. So source is 10.1.100. ICMP type. Now, sometime back, I told you about the ICMP part, if you remember. I told you the code 0 and code 8. Remember, I hope you guys remember that. See, somewhere here I had put it. So when you do a ping test, let's say this is inside, this is outside. Your ping code will be 8, reflected as 8 for echo request. For the written traffic, for the echo reply, that has code 0. So from the firewall perspective, you need to know code 8 and code 0. So you come back to this, you will say code 8 was your request traffic, reply you are expecting on code 0, do a question mark. It is asking you for the destination. So destination is this. Press enter. Inside one. Okay, let me check if I'm giving the right. 211.1.100. Let's see this IP once. Show IP 10.1.1.100. Let me do a 0 here. A complete network. Okay, this could be because that interface we have shut down. If I bring up the interface and then try gig 0/1, no shutdown. Okay, and then I try this packet tracer. See, now it will show you the complete packet tracer. It says that your policy is allowed. Okay, so from inside to outside, your input status and output status action is allowed. So which policy it's been considering? It's considering that ICMP stateful connection that you had applied. So you will see the packet flow here, the route lookup, the NAT, IP options, QoS, inspect. So under the inspect, you see your policy for inspect ISP got triggered up. And it says that you're all good. There is no deny from the policy as of now. Okay. So next thing, what would you do? You would try to see the packet capture. Let me first put this back. Let me put this as shut. Now you want to capture the packet. So to capture the packet, there is another command which is called as capture. Give it a name. Let's say in to out. Capture is this. You want to trace on interface which is inside, ingress traffic on a real time. You would like to match the traffic, otherwise this would take a lot of overhead. So don't run it for all the traffic, try to match it. So the traffic that you're matching is for ICMP. You can give any to any, or if you're specific about the host to host, then you can definitely give that. So let's say this host to this host is what I'm trying. So now you see that capture is ready. It is it is waiting for the traffic. So we will initiate the traffic. We will see that if I'm able to ping or not. So when I initiate the traffic, it will start picking up those traffic. You see all the traffic are sequenced 1, 2, 3, 4, 5, 6, and they are only shown up as one directional. That is 1.100, that is from inside to outside. You see the traffic type, only echo request is seen. So what does this mean? What does this mean for a firewall engineer now? So he's sure that the traffic is coming to the right path, right? So the capture right now is added here, and capture is showing only the echo request, but no reply. So all the traffics are trying to enter, but then they are getting dropped. And your policy say the policies are good, all allowed. There is no denial by policy. But the capture says it is entering, but it is not egressing from the outside interface. So the issue should be somewhere in the outside interface. So now what you do, you go back, you check the interface status once. So you realize that interface is admin shut. What would you do? You will go and bring that up now, no shutdown. And then you can once again execute the capture to make sure if this fix brings up it or not. So initiate the capture, and then initiate the test packet. So it's a reachable now. You should see both the traffic now. You see the request traffic and reply traffic. So in and out, both the traffics are visible now. So 1.100 to outside to 1.1 series, and from 2.1 back to the inside traffic. Okay, so these are some troubleshooting command. So guys, I'm done for the day. In the next class, I'll recap whatever we did in the demo class. Plus, I'll start adding the policies and we do the packet filtering, etc. So once again, let me just show you the curriculum of Firewall Mastery. As you guys know, this will take to the three different tracks. So you can opt either for Firewall Mastery, which consists of 5 modules, or you can go with CCNP Security, which is core plus ASA FTD paper, or you can go with CCIE Security, which would be score paper, ASA FTD, Cisco ICE, ESA, WSA, automation, and the CCIE Security Bootcamp. Okay, so for the firewall guys, these are the modules. These are the 5 modules. Let me show you the 3 tracks that's available. Yeah, over here. Over here. So I'm just gonna repeat once again. This is the first course, Firewall Mastery, which consists of 5 technology. We start with ASA here. This is a weekend batch. Someone who wants to go with the CCNP Security, this is the track that you can opt. Once again, this consists of 2 papers, core and ASA-FTD. So I'll first start with ASA-FTD. And for someone who prefer going with CCIE Security, which consists of various other modules, score, ICE, ASA-FTD, ESA, WSA, bootcamp, and also an automation topic, the third course. So for you also, I'll start with the ASA. So for the very first module, lot of guys will be in the same batch, but later on, the person who has opted for firewall would continue that. The person who has taken up the CCI or CCNP will accordingly follow that. Okay, so this is the pattern we have prepared. And regarding the fees, etc., you talk to my backend; they will guide you with that. Let me also drop their numbers, or you can just email or call up this number too. 1 second, let me show you. So this is what it is. Okay. Let me quickly show the firewall labs. So this was one of the firewall module lab, ASA FTD, which is a common paper for all the three track. Apart from this, the Palo Alto checkpoint F5. These are some labs that you would be receiving from us. So if you have any doubt, any further doubt, like number of the CCI track will not cover all other tracks, especially not the firewall module, because firewall module consists of multi-vendor solution. So CCI track is more towards the blueprint, the CCI blueprint. That's why I have put over here the exact modules that we would be taking up in CCI security. Yes, for if you need both, if you need firewall plus CCI security, you talk to my backend, and we can avail you this as well. Okay. Okay, I see a question. In the firewall mastery, will you explain the lab for site to site? Yes, definitely, because all the firewalls will have their own VPN. The VPN topic is also available in the security. There is a SVPN topic, which consists of around 11 different VPNs. This paper you will only see for the CCI security, guys. But for the CCNP, for the firewall mastery, you will see all the major VPNs like S2S, IPsec, SSL, remote access. The major ones you will see them. But if you want the dedicated VPN course, then that is a part of CCI security, not a firewall mastery. Yes, remote VPN is covered. Okay. Both in firewall mastery plus CCI security, remote VPN is covered. Regarding the CCI lab, we have our own official lab for the practice. You better talk to our backend guys, and they will guide you with the lab access and the number of month that you would receive this. Yes, Wasim, we are covering the traffic shaping bandwidth and utilization for firewalls. So the QoS policy, the QoS things will help that to understand. Yes, that's right, Donny. The firewall mastery is vendor specific. So we will cover the PCNSA certification for Palo Alto, CCSA for Checkpoint. For ASAFTD, we would be covering up the production and the CCNP level. For F5, we have 101 LTM module, and FortiGate, we would be NSC4. So this is from the certification perspective. Yes, wildcard is covered in the case of Palo. We actually have another dedicated batch for Palo, which consists of PCNSA plus PCNSC plus Panorama. We have this dedicated batch as well for Palo Alto, which is also starting the next weekend. So if I have to add one more, so apart from this three, if I need to add one more module, I can say in-depth Palo is also one more option for you guys. PCNSA, PCNSC, Panorama, and automation for Palo Alto alone. Okay, so it's your choice. Talk to the backend. They will explain you the complete curriculum. You can make the decision where you want to go with the firewall mastery, CCNP security, CCI security, or in-depth Palo Alto. Protocol, definitely, this is a part of routing. So every firewall you will be shown how to put the IGP and EGP protocols. And see, all our labs consist of a topology. We don't keep only the firewalls and just show you the dashboard. So let me show you our lab. So you will understand why this protocol is important. So if you see this lab, which is open, I have not kept just a firewall. I could have still kept it as a firewall. I would have told you this is a firewall class. Let me show you its feature on the dashboard. But that is not, you will understand end by end flow, right? So you need to have the routers, which is some side to side. So for that, you need to have the protocol done. Otherwise, the communication will not happen. We also have a bonus firewall topology that is especially in the firewall mastery scenario. So let me show you that. I have already gone through that. If you missed the previous class, just have a check on the firewall bonus lab. Let me quickly show you. See, once you, let's say someone takes up the firewall mastery 5 module, and after end of that 5 module, you would be given up with this massive topology. So this topology consists of multi vendors. You can build VPNs between 2 different vendors. You have MPLS connectivity. If you are a routing switching guy, you can have your own MPLS cloud. You want to have some scenario that from a user behind checkpoint wants to communicate with the URL which is behind the FI LTM. So end-to-end connection or end-to-end configuration you are supposed to make, because this lab we will give you as a scratch lab, as a default lab. So you have to put all the configuration from the PC, from the switch trunking, access mode, the IGP protocol, the BGP protocol, the MPLS configuration, right? So this is where you will learn all, bringing up the routing switching concept along with the firewall concept. So this is for firewall mastery, those who are preferring going with the firewall modules. For CCI and CCNP, this kind of a massive lab would be also present, but from the respective certification perspective. For CCIE topology, we will have various other nodes and all the requirement like IE server, ESA, WSA, ASA, FTD, FMC, the automation Docker, whatever is required for CCI. Same goes with CCNP. Same goes with Palo in-depth course. Same goes with firewall mastery course. Okay, so we believe on end-to-end troubleshooting. All right, so guys, I am done from my side. The contact details are put already in the chat window. If you want, I can keep it here. So you need to contact them and they will help you with the schedule enrollment process. Okay, so enjoy your weekend, and let's connect in the real class from next weekend. All the 4 batches are starting from next weekend, so just be a part of this. Okay, have a nice day and take care.